We've entered the era of the AI agent. It seems like every week there's a new product that claims to be an agent. But what is an AI agent exactly? How do they work? And how do we go about building one? So in this video, I'm firstly going to take you through the fundamentals of how AI agents work, and then we will build one ourselves using Vercel's AI SDK with surprisingly few lines of code. All you need to do to follow along is a code editor like Cursor or VS Code, and a basic knowledge of TypeScript or JavaScript. An agent is something that can take action and cause effects in the real world. But LLMs are by default just simple next token predictors. All they do is, based on all the text so far, what is the next likeliest token that follows the current text. So LLMs can't directly take action. They can't, for example, read or write files from a disk, or search the web, or launch a nuclear strike. An AI agent is simply a way to give LLMs power to do some of these things. Don't worry, we don't have to let the LLM do anything that we don't want it to do. So there are three fundamental properties of an LLM that let us build agents. The first one is that LLMs can take a problem and break it down into a list of steps that they need to do to solve that problem. And the second one is that LLMs can generate structured data when asked to do so. Structured data like JSON, for example, is machine readable. So that means you can take the output generated by an LLM and feed it into an ordinary computer program to then execute that action. And the third property is the ability to feed the result of the action back into the LLM thanks to its context window. Based on the results of that, the LLM can decide what the next action should be. So what does all of this look like in practice? Before we write any code, let's try this out by hand in a chat UI like ChatGPT. I'm going to use T3 Chat for this, mostly because I had an error trying to do this in ChatGPT earlier, but also because T3 Chat is just a nicer, faster UI in general. So what we're going to do is we're going to make a very basic customer service AI that works at a bank. Let's go to T3 Chat, and I'm going to paste a prompt here, and then I'm going to explain what the prompt is. I've written, you're a customer service assistant at a bank that helps people with their queries, or direct them to a human if you can't easily solve their problem. When a customer contacts you, you'll get an input in the following format: customer query, customer number, and customer name. In response to a query, use one of these available tools to help you complete your task. This is kind of where the agent side of it comes in. We're providing them with a way to either talk to the customer, check the user's balance, list the latest transactions, search a knowledge base, or pass on to a human. And we said, remember to only use the tools above to complete the customer's query and nothing else. This also ensures that the LLM won't generate random text that we couldn't then turn into an action ourselves. When you use a tool, the result of using the tool will be fed back to you as input. Normally, this would be part of our computer program. In this case, we're going to do that bit ourselves. If you're ready, reply with ready, and you will receive your first query. So let's now send this using Gemini 2.0 Flash, and we just get the response back, ready. Great, so let's now come up with a customer query. So what I'm going to do is I'll just paste this here to help us format this query. So the query, let's say, is, could you please help me check my balance? Let's invent some customer number here, some 9-digit number. And then I'm just going to say customer name is John Smith. So let's go. Cool, so we already see immediately that the AI is using the tools that we provided it. We've got check balance with a customer number, and what I'm going to do is reply with the result of this tool. So I'm going to say tool result minus 14,500 USD. Okay, so now the agent is talking to the customer, saying your current balance is 14,500 negative dollars. Now, let's say the customer is a bit confused by this. So let's say customer response so this is really unexpected. I wasn't expecting a negative balance. Could you please help me understand why I'm in debt? Okay, so now the agent wants to list latest transactions. Makes sense. Let's try and find out what has happened in their account. So let's say tool result is, and I'm going to put just one transaction in here saying, let's say amount is minus 14,500, currency USD, description, payment to Scam McScamerson. So we're now talking to the customer with the message, it seems that a payment was made to Scam McScamerson. Did you make this payment? Let's say customer response. All right, so maybe we're being scammed here. So what can we do? All right, so we've said pass on to human, customer reports fraudulent transaction of $14,500 to Scam McScamerson. This is already pretty incredible that you can do this. Like, we're manually creating an agent here, but you can imagine that the responses themselves will easily be automated out, and you can build a customer agent that seems to do the right things when working at a bank. So now let's look at how to build this in code. If you've built any kind of software before, you might notice that the interaction we just had with the LLM was pretty straightforward. All we have to do is feed it a prompt, a list of available tools, and come up with a way to execute the tool result that comes back from the LLM. And then once we've got the result, we feed that back into the LLM to complete the loop. So the LLM interaction is a pretty small bit of building an AI agent. The rest of it is all in the tools. But that being said, there is still a lot of grunt work involved in building the LLM interaction. We need to, for example, come up with a consistent interface and language for calling the tools. We need to make sure that the LLM outputs are valid. And we also need to make sure that the tools are valid, that the LLM hasn't hallucinated the tool that doesn't exist. So all of this is where Vercel's AI SDK really comes in handy. Instead of building all of this scaffolding ourselves, Vercel's basically built a way to build all of this using essentially a single function call. So let's now get into the code and I'll show you how we can build the agent. So the first thing we'll need is a function. Let's call it agent. And what we're going to do is use AI SDK's helper function called generate text. So we're going to say generate text, and cursor's already predicting what we might be asking for here. So let's say model, yes, Anthropic, Claude 3.5 Sonnet. And the other thing we can type is a prompt. So in this case, let's just say test. So this is a pretty simple LLM call. Let's make it slightly more complicated. Let's add the tools list. So let's first start with the check balance one. Okay, so check balance, description, check the balance of the user. And here we pass in parameters, which takes in a Zod validator. That's really handy to make sure that the parameters that the LLM uses to call this tool are going to be correct, because they'll be validated before it reaches the tool. So in this case, let's say indeed customer number, and let's import Zod here as well. And then we have this execute function. And execute is where the magic happens. Here we can do kind of whatever we want. We can log stuff, we can fetch things from a bank account. In our case, let's just return a placeholder for now. So let's say the balance is negative 14,500 with a currency of dollars. Now the other tool we might need is to list the user transactions. Let's write that one as well. List transactions of the user. And cursor's mostly completed this for us. Let's just add a few fake transactions in as well though. Let's say the last one's $1,000 and a couple $1,000. And then the third one, let's make it so that we add up to about 14,500. So let's say 13,500. I'm going to give this a description of payment to Scam McScamerson. And then the final tool we're going to need is to pass on to a human. So pass on to human. This is going to hopefully be called when the AI is just not quite sure how to deal with the query. Okay, and we don't really need to do anything here. We can maybe console log something saying passing on. Now, one thing we haven't done yet is to pass in the correct prompt for this question. So let's start by adding prompt as a parameter to agent. So we'll pass in a string initially, and the way we call this will be, let's say, customer query. I would like to check my balance. Customer number, some random 9-digit number, and customer name, let's go with John Doe, as cursor suggesting it. And then we'll put this prompt into the generate text prompt. Great, so it looks like we're almost done, but there's one thing missing here, which is we want to be able to interact with the customer. If the balance is, for example, negative 14,500, we then want to pass that to the customer and then wait for their response to be able to have a conversation with them. But you might notice that the generate text function just does a single call with a single prompt to the LLM, which is not quite going to be good enough for us. Instead, what we want to do is to wrap this in a loop. And we can do something quite simple here, like a while true. And the other thing that we don't quite have is the history of the conversation. So now that we've wrapped it in a while true, every time we make this generate text call, there's no history, there's just a single prompt. And even if we made that prompt related to the response that we got from the LLM, it still doesn't contain the full history and the tool use and the response from the tools, etc. You might be thinking, surely AI SDK has made that easier than doing it all ourselves, and you'll be right. All we have to do is, instead of passing in the prompt, we pass in a list of messages instead. And the first message will be what cursor is suggesting here, which is role user and content prompt. But we want to actually make this dynamic so that each iteration of the loop will contain more and more messages. So let's make messages now into a variable. And actually, I want to take that outside of the loop. And inside the loop then, what we want to do is we need to append the result of the LLM to the messages. So we'll do messages.push result dot, and I need to await the results. And we do need to make this async then. Great, so we have result dot. So we want to actually just concatenate these. Let's make that into a let so that it lets us concatenate them. Okay, here we go. So after a bit of battling with the exact result type, we've got the new messages array, which is now a list of previous messages plus any response messages that we got from the LLM, which will, if you look at the type of this, it will include tool calls as well. And that's kind of what we want here. We want the entire history of this conversation, including anything that's happened, and AI SDK gives us that. But what are we doing with these messages? Well, the first thing we want to do is get back to the user with a response to their query, and then we want to wait for their input. And the way I want to do that is let's open a console prompt using the readline Node.js library. We're going to use readline.createInterface. And we have an input and output. We pass in process.stdin for input and process.stodout for output, so we can interact with this via the terminal. And let's import readline as well from Node. Okay, so now we have this readline interface. Now, after we have our message, we can do what cursor is suggesting here, which is to ask a question, which is a nice interface that readline provides. So in this case, we don't actually want to output anything because we will have logged everything that's coming back from the LLM directly to the console. So there's no extra question to ask. Actually, we might as well just say, type in your answer below, which will prompt the user to say something, and then we'll add that to the messages as well. And let's actually just move this one above so that the user's message is the last one. Okay, so the only thing we're missing, I think, is to actually log these out to the console. So let's actually first log this. We also need to wait for the question. We need to make a promise out of this. Okay, so just to explain what we're doing from top to bottom here, we have this generate text call, which is just an LLM call with an available list of tools. And the way this works is Claude will receive our prompt, and it will also receive an extra prompt to say, use any of these tools to answer the customer's query. And it will then decide whether it needs to use a tool or whether it needs to get back to the user, or whether it will just output some text for us. And so we pass in any messages that have previously been sent, including the user's messages. And once the response comes back, we will then log that, append it to our existing list of messages, and then wait for the user to interact with our prompt. Cool, so let's now try calling this and see what happens. Okay, so of course, we're actually logging the entire message object, not just the text. So let's actually do for each message. Yeah, we want to log the content, but only really if the messages got an assistant role. We don't really want to log tool calls on a command line. So what we actually want to do is have another loop here. Let's say content. Okay, so we just want to log either strings or content type equals text. That should just give us the messages for the assistant. Here we go. So we have certainly, I'd be happy to check your balance, John. Since you provide your customer number, we can proceed with checking your balance. Okay, so I just realized one more thing that we're missing that we didn't quite do. And that is that we actually need generate text to act like a mini agent for every call. What I mean by that is right now, there's this max steps parameter that is limited to 1 with every generate text call. And that means if the agent decides that the prompt requires tool use, it can't actually use the tool within that same call. So let's put max steps equals 10 here. And that means for every query, every prompt, the agent can do 10 different things if it needs to, including talk back to the customer. Okay, and now that we've got that, let's once more run our agent.ts file. There we go. So now we finally have what we want, which is that the agent has said they'd be happy to help, and let's use the check balance function. And they've also given us the balance of the bank account, including a nice, helpful assistant-like message to say, is there anything else I can do for you? So let's type in our answer. Let's say, why is my account so overdrawn? Let's wait for the agent's response. Okay, so response has come back. We've got our agent checking the list of transactions. Claude has indeed picked up on the fact that we have this massive payment to Scam McScamerson. And it thinks that the transaction name is concerning. I agree. And then at the very end, we have, would you like me to pass this on to a human representative, which is exactly the tool that we gave it that it can do. So it's actually suggested using that tool to the user. Let's say, yes, please pass me on to a human. This is an urgent matter. Great. So we have passing on to human. Yeah, so here's an additional sort of question to end this with. We can obviously tweak how the agent talks to you. So at this point, we would probably not want it to say anything, but our simple agent is working pretty well at this point. So now you might be wondering, well, this agent is doing what we want it to do, but the response comes back really, really slowly, especially if multiple tools need to be used. And this is why if you go on ChatGPT or Claude, you're going to notice that the text streams back to you as soon as it's being generated. So let's now look at streaming the text instead of waiting for the response. All we need to do is a couple of changes. The first one is to move from generate text to stream text. So let's change this to stream text. And as you can see, the interface is almost exactly the same. The inputs don't need to change at all. We've got our maximum steps, we've got our messages. One thing we do need to remove here is the await, because we cannot wait for the final response before we start showing things to the user. And instead of waiting for the messages, we also need to start dealing with chunks. Vercel's essentially abstracted away the idea of different things that can be streamed back to you into a concept called chunks with defined types. To make that work, I'm going to do another for loop here. Over this concept called full stream. So we're going to do result.fullstream, and each chunk here we will wait for, and then we need to switch on the type of each chunk. So chunks have a type, and the types can be things like error, finish, or reasoning. We also have text delta. That's actually going to be the main thing we need here. So if a text delta comes, let's do process.stdout.write chunk.text delta. We can't really use console.log here because console.log ends with a new line and we have chunks of bits of tokens streaming back from the model. Let's also deal with the error case, just because we don't want any errors to fall through and not say anything. And in the case of an error, let's just console.error chunk saying error. Great, so now we've converted this from waiting for each message to a streamable object, and then we iterate over the chunks of the stream and write them to stdout as they come through. One thing we still need to do is to write the messages, concatenate them into our messages array. So let's do that by saying response equals await result.response. So at this point we do need an await statement, and then concatenate with response.messages, and then we wait for the user to type something. Great, so now let's try running this and see what happens. There we go. It was as easy as changing a couple of parameters, and now we have streaming implemented in our assistant. Cool, so we've built our agent, which is able to use tools to figure out how to help a user, and it can decide on its own which tools are most useful for each query. It's easy to imagine how you could build a real bank customer assistant here if you just gave it all the tools that an actual assistant had, and the models were good enough to select from, say, thousands of tools. You can really start seeing how the first point of contact for every query could start becoming AI.